Good morning, class. Let's look at example 11 on the notes, page 9. It is given that g of x is equal to x squared plus 3 and h of x is equal to 2 minus x. Find g of x minus 2 and h of 4x. G of x minus 2. You need to replace x in g of x with x minus 2. Where it was x squared, now becomes x minus 2 squared. And then you will simplify your finding. Further simplify your finding. The answer is x squared minus 4x plus 7. Second, h of 4x. Where it was 2 minus x, with x replaced by 4x, you have 2 minus 4x. This one is already simplified. Now pay attention. I have to emphasize one concept here is that what you're doing is not to find a value. What you're doing now here is to get a new function, and here to get another function. Now, when you find function, you do not find value. Okay, it's still an expression. Part B. Solve the equation g of x minus 2 plus 2 times h of 4x equals 0. This one, when you put these two new functions together and then require the sum equal to 0, then this thing is no longer a function but an equation. Let me do the substitution. G of x minus 2 is x squared minus 4x plus 7. H of 4x is 2 minus 4x, but you need to multiply the function by 2. Okay? If I do not write equal to 0, then it's still a function. But because it's equal to 0, it's not a function anymore. This is something that x has to satisfy, and not many values satisfy this equation. And we need to find the values that they do. To solve the equation, you need to simplify the equation. Further simplify the equation. Factorize the equation. And then you have two roots for the equation. Okay, so my suggestion is that you do not blindly just do, oh, I just do substitution. Yes, you just do substitution, but you must know what you are getting. This time you get a value, next time you get a function, and next time you get an equation. And what they are is very important. You can pause the video because we're going to do an exercise from the textbook. Page 22, instant draw 11. Now you are finished. Look at the answer. F of 2x is a new function. It's equal to 4x plus 1. G of x plus 1 is a new function. It's equal to x minus 1. F of 2x times g of x plus 1 is equal to 9. This one is an equation. You put the two new functions inside. You have an equation you need to solve. And then you have the final answer, negative 5 over 4 or 2. Okay? I hope there is no confusion at all. Next question. Example 12. In a private car company, the cost of producing n private cars is represented by the function dn. And the expected repair cost for n private cars is represented by the function Rn. Each private car is sold at $100,000. Let P of n be the function representing the profit of producing and selling n private cars. Can we find P of n in terms of n only? I think we can. We will use the $100,000 to get the selling price of n private cars. 100,000 n minus the costs. The first cost being D of n, 3 million plus 50,000 n. The second cost being R, that is 9,000 plus 16,000 n. This is the money earned from selling n private cars. Let me simplify this function. This is equal to 34,000 n minus 3,009,000. Okay, that's it. Now in the equation, you do not write any unit. Now do not put dollars here because P of n is in dollars. It's said you don't have, you see the R of n has no dollars. D of n has no dollars. So P of n should not have dollars. Okay. It's an easy question anyway. Part B. This one is not easy because it said if an actual profit is made, can you find the domain of the function? The domain of the function. Now you need to understand this question is very weird. What is the domain of the function? Now, the domain of the function refers to the range of the independent variable. The range of the independent variable. Now, usually the independent variable is represented by the letter x. But in this case, it's not x. Usually it's between x and y. X and y. X is the independent, y is the dependent. But this time is not. It's p and n. Okay? N is the independent variable. And p, the profit, is the dependent variable. So if you are not very familiar with the terminology, find the domain, then you can translate this to a familiar language, that is to find the range of n. Can you find the range of n? Okay. Now, because this is a practical problem, so n is restricted by a lot of things. For example, n should be a positive number, right? Because I have n cars. I cannot have negative cars, okay? And also, n must be integer because I cannot have 0.4 cars, okay? So there are a lot of natural restriction as to what value n could be. Plus this additional constraint. In this question, it says, this is additional, I said, because it's not natural. You cannot say in the world that a profit can be made naturally. It's not. It's additional. Additional constraint is added. If an actual profit is made, so n is more restricted. How can we find the range of n? I think we can find the range of n by solving an inequality. Since the actual profit cannot be negative, I will say that the profit 34,000 n minus 3,009,000 cannot be negative, must be greater than or equal to 0. Right? And then I can find n is 3,009,000 divided by 34,000. N is greater than or equal to 88.5. This is an additional range I find for n. Now the answer. Now in the answer, I must state what n can be precisely, plus this additional constraint, plus all the natural constraints. So the domain of the function p of n is all positive integers. You see, I do not say positive number, I say positive integers greater than or equal to not 88, but 89. I think the smallest is 89. Do you agree? Okay. Now let's go back to the previous lesson where you need to find the domain. I think it's here. It's here. Sorry, I couldn't find it. Now, in the earlier part of this lesson, 4.3, on your notes, page 7, you can find another question requiring the domain. You see, like example 4, find the domain. Right? Find the domain. And at that time, you are facing a function that is abstract without any actual meaning, meaning that I don't know what y is, I don't know what x is. But right now in example 12, the functions that you are facing now have an actual meaning, like P is the profit, N is the number of cars. So it's a different approach to find the domain for these two types of functions, one being abstract with no meaning, one being meaningful and of like actual background. So with these questions, you have to find the domains through like many constraints in real life. Many constraints in real life, like, oh, there is a profit, like, oh, there is the number of cars has to be positive, something like that. These are practical, real life constraints, okay? Whereas the abstract function in example 4, you don't have any of those. You don't have a profit, you don't have the cost, nothing. In these functions, you find the domain according to the function expression itself. Like, for example, if you have a fraction, then the denominator cannot be 0. Okay? So, to question example 12, the answer for part B is all positive integers greater than or equal to 89. You can never find that just through by looking at this. Okay. Now part C. Part C. It is given that 250 private cars are produced and sold. Find the profit. Very easy. Profit of 250 equal 34,000 times 250 minus $3,009,000 equal $5,491,000. You do not write dollars there. The required profit is dollars, $5,491,000. Next one. The manager of the car company claims that if the repair cost is doubled, the company can make a profit of $1,500,000 from producing and selling 250 private cars. Do you agree? Now let me try to understand what the manager wants. The manager says that the repair cost is doubled. He doesn't mention the other cost, the producing cost. So let's assume that cost is unchanged, right? And the profit is 1,500,000 from producing and selling 250 private cars. I think that's a very easy statement to verify. I just need to find the new profit, right? Okay. If the repairing cost is doubled, so my profit is equal to selling 250 cars minus the same producing cost, 3,050,000 and 3 million plus 50,000 and, but here is 250, but minus twice of the repairing cost, 9,000 plus 16,000 and 9,000 plus 16,000 and we just need to find it again. And this value is greater than or smaller than? Let's find out. Let me try again. Why do I get 1,500,000? Oh, I made a mistake here. It's 50,000, not 15,000. Yes, 1482000. and this is smaller than this one, smaller than 1.5 million. So the company cannot make the claim is disagreed. Okay, now you can pause the video and go to the textbook for the exercise. On page 24, instant draw. Part A, you need to find a function. Part B, you need to find the domain according to the actual real life situation. Part C, you find the area. Part D, you verify a statement. Part A, the length of the other side is equal to 24 minus 2x divided by 2 cm. You see, some students ask me, oh, Ms. Chen, should I write cm every step? Yes, you should. I think in the past, your teachers were kind enough to let it go if you didn't write it. But you should, you see, you write it every step. I'm not kidding. And then the area is equal to, you see, cm. Area equals cm. And the expression of A does not have a unit. Okay? Now, part B, what is the domain? The domain, you see, obviously, this is one constraint, right? One constraint. Where do you get that? Because it's a length, right? You get it from actual real meaning of x. And second one, the other side must be positive, right? How do you know that? Because you have to search for it. Sometimes it's very obvious, like the number of cars. Sometimes it's not so obvious, like this one. You have one side that's obvious. This one is obvious, but this one is not so obvious, but it's not so difficult to find. You can be observant and then figure out. Because of the actual meaning of 12 minus x, it has to be positive. Therefore, x has to be smaller than 12 as well, at the same time bigger than 0. Therefore, the domain of the function is all real numbers greater than 0 and smaller than 12. Okay, you can never get that from the expression. You must get it from the actual meaning of x. Okay, now let me guess. Some of the students also figure out something else. For example, they may say, oh, Ms. Chen, I also know that the area should be positive, right? I agree with you. I agree with you. You can say the area is positive. However, if you set up an inequality saying, oh, area 12x minus x squared is greater than 0, unfortunately, you are unable to solve this inequality. I'm so sorry. Agree? Therefore, you cannot get anything from this. Right? Oh, I'm not saying this is wrong. This is correct. It's one of the constraints. But you cannot solve it, so you have to give it up. And if you think it back, one side is positive, the other side is positive. I think these two constraints already have covered the area being positive. Don't you agree? I mean, if you say one side is positive, the other side is also positive, and then you say, oh, the area is positive, I think the last statement you make, isn't it a little bit redundant? Isn't it? Think about it. Let me know if you have any question on this one. This is not so easy. This concept is not easy. Not easy. Part C. The area when x equals 3. Substitution. In here, you do not write unit. In the statement, you write unit. Part D. If the area is 40, can you find x? This is an equation. An equation. You find it. And then when you are solving, you find, oh, it's impossible. It's impossible to find the root, a real root. Therefore, you say, oh, the discriminant is negative. Therefore, nothing satisfies. There is no real number x. Forgive my language. Sometimes I don't say the standard language. Nothing satisfies means there is no real number x such that the equation holds. Therefore, it's not possible. Okay, please do the homework today. Bye-bye.